Do. Aha, this appears to be working. Good. Hang on a moment, folks. There we go. Just working on a few issues here. Because G+ changed a couple of things, I had to go back to some old directions to figure out how to set this all up. Let me make sure it works. There we go. All right. I just have to do a couple of things here to get this working for me. I want to make sure you can all hear me. If you can hear me, leave a comment in the comments, right? Hello. Of course. All right, so let me put this up on Twitter. I'm doing my Q&BA video chat live right now on G+. There we go. And I will send this. Okay, so now it's up on Twitter. And I will refresh the page with the Hangout. People can hear me, unlike the last time I did this when I talked for 15 minutes and nobody could hear me, and that was very, very embarrassing. So hopefully, yeah, so there's my logo. People say they can hear me. It's up on Twitter. I do believe that we are ready to go. Okay. Give me a sec. I'm still trying to figure a couple of things out. Missing a window, missing a window. Where did it go? There it is. Ah, okay. Sorry about this. Just give me a moment. It's been a while since I've done this, and I'm trying to remember how to do everything. I want this here. I have to open several windows to make sure that this is done correctly. And there are a few issues with doing that, but it appears to be good. Yeah, there will be video in a sec. If you're hearing me but not seeing me, that's because I have a splash page up right now that just shows my slogan there. Okay. Tell you what. Hello! Hey, hope y'all can see me. I see me. Here we go. Left, right, left, right. Okay, cool. And I'll refresh the page to make sure that now you all still see me. There we go. Okay, hey! So today is April 15th, 2012, and my name is Phil Plait. I am the Bad Astronomer. That's what I call myself, at least, because I write the Bad Astronomy blog for Discover Magazine, and the Bad Astronomy website, and I Twitter under the handle Bad Astronomer, and there's probably other bad stuff I do as well. Today, I also want to point out that, as always, oh, for Pete's sake, there we go. As always, Q&BA is brought to you by Science Getaways. I hope you can see that. There we go, yeah. There's a little bit of a lag here between what I'm seeing and what's actually going on, so sorry about that. Science Getaways, vacation for your brain. This is a company my wife and I have started to take normal vacations and add science to them. And our first one is in 2012 in September. Go to sciencegetaways.com and find out about how we're doing a dude ranch with a geologist, a biologist, and me, an astronomer. And we'll be doing hikes and talks and going out and looking at the stars. It's going to be pretty cool. I'm very, very excited about this, and I hope some of you can join us there. By the way, Q&BA is not actually brought to you by Science Getaways. It's just something else I'm doing, but what the heck, I'll make it look like that's what's going on here. All right, I'm going to do one more fiddling here. Got it. Okay. Hangouts on G+ are a little funny. There's a separate window that shows me what I'm doing, but I also have another window open that has the comments in it so that I can see those. But it also shows me and me, gesticulating and doing all that stuff. But it's a couple of seconds behind what I'm actually doing, which is really hard to not look at. And, oh, I'm looking at the screen, and I look like a total dork, which, fine, I look like a total dork anyway, but there's no real need to amplify that more than is necessary. Alrighty, so if you're on Twitter, you can ask me questions there. I'm just glancing at that very quickly. Okay, no questions on Twitter yet, which is fine. So Q&BA is like Q&A, except with me, the BA, so it's Q&BA. It's adorable, isn't it? I want to do these things every week on Sundays at this time. It's been ridiculous the past few weeks. I've been traveling a huge amount for various and sundry things. I went on vacation with my family, but I've also been giving talks and everything. And so what's been happening is even when I'm traveling, like on Monday, the day after I would normally be doing this, if I'm gone for a couple of days, I have to write the blog in advance because while I'm traveling, it's very hard to do that, and very hard to at least keep up with the blog. So that means all day Sunday I'm like panicking and writing stuff, and it makes it very hard to do this because it's more than just the hour I spend talking at you on the camera. There's some editing and video stuff I have to do as well to set it up. So the past couple of weeks I've been able to do this, and I apologize. The last time I did do this, there was this massive microphone failure for 15 minutes, which was thrilling for all of you, I'm sure, and screwed up one of my better answers. I was actually really upset about that. And it's the kind of thing where you just can't do it again. It's hard to capture that kind of thing twice. So let's see. Before I start taking questions from you guys, and be welcome to ask questions in the comments, or you can tweet them. If you are on Google Plus and you're signed in, please +1 this Hangout. Gosh, where did they put the +1 button now? I think it's the bottom right now of the window where the like the embedded YouTube video player is. Yeah, I see it there now. Feel free to share it, but that way I can get an idea of how many people are in here. It's actually kind of hard to know, and I'd like to see those numbers growing every week, of course. So just a couple of announcements first. I blog again for Discover Magazine. Just search for Discover Magazine. Well, it's blogs.discovermagazine.com/Bad Astronomy. If you type Bad Astronomy into Google, you'll find it. I'm on Twitter, Bad Astronomer, Google+. I've got a Pinterest page now, which I'm putting some stuff up on there. If you search for me there, you'll find me. I started a Tumblr, but I'm still not using that much. I find that to be a lot more work than I think is probably needed since I've got the blog. I'm still wrestling with that, so I'm not sure what I want to do about it. I've mentioned Science Getaways. I'll mention that again later. Two things I do want to mention. Today, as far as astronomy news goes, Saturn, the planet Saturn, is at opposition. And what that means is that as the Earth is going around the Sun and Saturn's going around the Sun, right now, roughly, the Sun, the Sun, the Earth, and what the heck, I'll use my Milky Way model as Saturn, are basically on a line, right? The Earth is going around the Sun, and Saturn's going around the Sun, and so they're not always lined up. But right now, they're roughly lined up. It's not a perfectly straight line, but basically Saturn and the Sun form a line, and Earth is closest to being on that line as it gets all year. And that means that to you, standing on the Earth, the Sun and Saturn are on opposite sides of the sky. So when the Sun sets, Saturn rises. Saturn's up all night, and then when the Sun rises again in the morning, Saturn is setting. Since they're opposite each other in the sky, that's called opposition. And the important thing about that is that that means that the Earth and Saturn are roughly as close as they can be during the entire year until the Earth goes around the sun again and you get another opposition. That actually takes a little bit more than a year, about a year and a month, something like that. So right now, Saturn is as big in the sky as it can be all year. And because of the way the orbits all line up, it's going to be fine. If you can't see it tonight, you can wait a week. You can wait a month and look at Saturn. It'll still look awesome. But if you look at it tonight, it'll be the best. If you look at it tomorrow night, you won't see the difference. It's not going to look any smaller through a telescope, really, unless you're taking high-resolution images and you compare them. You'll see it's a little bit smaller tomorrow night than it would be tonight. But that's not really anything you'd notice by eye. So if you have clear skies and access to even binoculars, go outside and look at Saturn. You can see the rings even with binoculars. And as you get to bigger and bigger telescopes, it looks better and better. It wouldn't surprise me if there are some observatories that are having public nights to look at Saturn. You can look that up. Every day I publish a fact I call BA Fact on Twitter and Google+. I put up a link on both today that take you to the Earth Sky website, and it has a long description of all of this. And if you can get out and look at Saturn, man, I cannot recommend that enough. Saturn is spectacular, and it was actually when I was a little kid looking at Saturn for the first time through a small telescope that hooked me on astronomy. So if you have kids, take them out and do that. Believe me, it's the thing to do. Also, for those of you who don't follow me on the blog, and if you're following me here, honestly, and you're not following me on the blog, hello. But every day for the past 3 weeks now, I've been publishing something I call my desktop project. If I were to share my desktop with you, actually, I probably can. Nah, I won't bother. But I've been saving, every time I get news about astronomy stuff, and there's some cool picture, what I usually do is save it to my desktop right away, and that's a reminder for me to use Photoshop to make it fit on the blog and then upload it to my blog and write something about it. And the problem is these things can come in so quickly and other things happen, like I travel or other news comes in, and I can't write about them. So it was getting so cluttered. I had like 25 images sitting on my desk. I decided to start what I call my desktop project, and it's a way of forcing me to write every day about one of these pictures. And it clears off my desktop, and it's, a lot of people like me do better with deadlines. So, if I know I need to write something every day about something, then I'll do it. And so by forcing myself to do this, what I call this desktop project, I've been writing every day about something or posting every day. And it's actually been working out pretty well. And I think I posted the 21st one today, the 20th, 21st, something like that. I've only got a few more, and I've been saving a couple of really cool ones for last. So pay attention there. If you go to my blog, you can see those, and they're like just tons of awesome pictures with usually fairly short descriptions of what's going on. And I just wanted to let everybody know about that. Now, let's see. Now I can look at the comments. You know what? Let me refresh the comments. And while that's refreshing, I'll go to Twitter, and I'll check to see what's going on. See, I wear these glasses because I need to use them to look smart. But when I have to read something on the screen, I have to pick them up. And I think that makes me look like an old librarian or something. People making fun of Google+. That never gets old on Twitter. Let's see. Well, start off right away here on Twitter. Here's a good one from You Really Kicking. No, I'm not. You Really Kicking on Twitter asks, how do you feel about Dragon X going to the space station? Dragon X is the space capsule that is being built for the Falcon 9 rocket by SpaceX, which is a private company run by Elon Musk out of Texas. And although he's got places in California and all kinds of stuff where they're building these rockets, and it's the, I need to think about this a little bit more. The claim is it's the first private company going to orbit, but there are other companies that have built rockets. This NASA doesn't build anything; they contract that all out. So the space shuttle, the Saturn V, Deltas, Atlas, all these rockets are built by companies, but I guess these are publicly owned companies, and they have NASA contracts. And so when you say SpaceX is the first privately owned company, it's a little bit of a technicality, but the good point is that they built this from scratch, I think is the bottom line with SpaceX. That's why I'm a big SpaceX fan, is that this was built from the money Elon Musk made from PayPal and other ventures he's done. And now he has NASA contracts once he was able to show that he could do this. And the Falcon 9 has already gone into orbit. it's taken up some stuff and brought the Dragon capsule. They've had one launch of the Dragon capsule where that went up into space, did 2 orbits, and then they brought it back down. And it all worked pretty well, actually. So they have a contract to launch a Falcon 9. It's been delayed a little bit, but now the launch is supposed to happen at the end of this month, at the end of April. And so it's going up to the space station, and the Dragon capsule, which looks a lot like an Apollo capsule, except it's actually white, not silver, and it's bigger. The Apollo capsules were really, really small. Those guys were wedged in there. But the SpaceX Dragon capsule is going to dock with the space station, and I believe it's going to bring some supplies. I would need to read up on exactly what's going on with what it's bringing up there. But the whole point of this mission is to get the Falcon 9 into orbit, take the Dragon, made it to the space station, and show that this all works. And if it works, then that means that Dragon can be used to bring supplies up to the space station. Right now, the only way to get food, air, water, supplies, and all that to the space station, and to bring trash and other stuff that they don't need that builds up on the space station away, is using either the Russians, they have their rocket system, or the Europeans, they have their ATVs, the automatic transfer vehicle, one that just made it to the space station last week, I think it was, that brought up supplies. So right now, that's the only way to do it. The more we have, the more ways we have of doing that, the better. That way, if there's a problem with the Russian launchers, as we've seen has happened, then and if the Europeans, if there's a problem, there's a third backup, and that's always a good thing. So I'm all for this. I think it's fantastic that we can do this. Right now, NASA doesn't have any way of bringing supplies or people up to the space station except through other countries. There is some amount of national pride here, and I'll freely admit that. But also, I like the idea that private industry is starting to do this. I don't think NASA should be in the business of doing the routine, and I've written about this many times. If you look up NASA and SpaceX and on my blog, and there's a number of other keywords you can think of, private industry, routine, look up routine, or truck, because I mentioned that NASA was calling the space shuttle a space truck many, many years ago. And I don't like that. I don't like the idea of them routinely launching rockets into space. I don't think that's what NASA's for. I think NASA is for exploration. It's for breaking new ground. And then once we understand how to do stuff, then it should be given over to somebody who can do it much more cheaply. Governments tend not to do things cheaply when they're routine, and that's just historically true. So I think it's better to hand that off to somebody who's trying to make a profit so that they will do it as cheaply as possible but still get the work done. You know, it doesn't help anybody if SpaceX blows up a rocket, so they're going to be as careful as they can, but they can do it more cheaply. And I think that's the way to go. So, yay, I love this idea. All right, so that's one from Twitter. Let me refresh the comment page. Oh, look, I got 40 comments already. Oh, and how many pluses do we have? Oh, now it's not showing me how many pluses are on it. Oh, that's funny. Okay, well, it has as many as it has. I'm not going to worry about it. Marcus Vinicius Petri, who I believe ruled Rome from 114 to 89 BC, says, looking at that shelf behind you, I wonder what books are those. It's very interesting to know what people read. Can someday you make a video showing your books and what's your thoughts about them? It's funny, I remember when I was doing some live streaming, years ago when live video streaming was really new and a lot more difficult than it is now. Not that it's easy now. I did that, actually. I was always getting people asking me what books I had, so I kind of did a tour of my office. It's hard to do right now because I'm doing this through a video camera that's a webcam sitting on my monitor, and so I can't pick it up and kind of show you around. Plus, my office is a hole right now. I let it kind of get really bad and then go on a fury of cleaning and clean everything up, and I haven't done that in a couple of weeks, so it's pretty bad. Just looking around at it right now. I could probably, if I tried to zoom in on that bookshelf, I'm looking at the controls right now, I would probably totally screw up the feed here, so I'm not going to do that. But maybe what I'll do is something like what Will Wheaton does. He does these short, dumb videos. I think he calls them stupid videos. And I'll use my phone on my camera. which I can't get G+ to work on this. I've tried many times, and G+ and Apple, for whatever reasons, the software that G+ puts together, the Google puts together for Apple stuff doesn't work terribly well. And I've complained about that, and hopefully someday that'll get fixed. But I can take you on a little tour of my office. I've got some really cool stuff here I've collected over the years. Some of it's ridiculous, some of it's just fun. A lot of it's pretty geeky. But as far as the books go, up here, let's see, up here, that's my Death from the Skies and Bad Astronomy shelf, mostly. I've just got copies of my books in different languages and stuff it's been printed in. I've got a bunch of astronomy and skeptic books, some science fiction. I've got a bunch of Scott Sigler books up there. Scott Sigler is a friend of mine who just wrote Nocturnal. His new book just came out, as a matter of fact. He writes science-based horror books. They're fiction. But Scott's books are awesome. If you've read The Infected, well, it's going to be a trilogy. The third one he's just starting to write soon. But his other books are great. And maybe what I'll do is I'll do a tour of my bookshelf one of these days. Because I agree. I think whenever I see books on a bookshelf, I'm drawn to them immediately. It's very distracting when I'm watching Big Bang Theory. I always look at the books on the shelves when they're talking, and I miss dialogue. And it's funny to recognize books on the shelf from authors I know or books I've used. And they have a Halliday and Resnick physics book on their shelf, and every time I see it, I want to run away screaming. If you've used that book, you know why. Let's see. Colin Mason asks, I have a question. What is the story behind your avatar on Twitter? My Twitter avatar is a drawing of me as a baby by Zach Wiener, who does Saturday Morning Breakfast Cereal. I only read 4 or 5 web comics. Saturday Morning Breakfast Cereal, XKCD, of course, questionable content, Tree Lobsters. I'm forgetting like 100 of them, but yeah, I peruse some of them, but there are a few of them I subscribe to. But I think Saturday Morning Breakfast Cereal is my favorite. Zach is a total geek, very, very, very smart guy, and a lot of his comics are based on science and math, and I love that. And he draws babies a lot, and he uses them as a foil for some sort of existential, philosophical rambling with their parents. And it always cracks me up. And I sent him a note. I've known Zach for a couple of years now. He's drawn me into several of his comics. He draws Neil Tyson and other scientists into his comics sometimes. And I told him how much I love the way he draws babies. It cracks me up. And he said, "Do you want me to draw you as a baby?" And I said, "Yes." So he's got me there floating in space with a onesie and a telescope and a beard, and I love it. It's so funny. I've had it as my avatar for a long time. I get a lot of questions about it. I rarely answer them because I think it's actually funnier when people don't know the joke, because I'm actually very cruel and evil. Let's see. Oh, people are putting up links. Yeah, if you want to put up links to stuff in the comments, feel free. If I talk about some topic and it's hard for me to sit down and do web surfing and everything, sometimes I do that because sometimes a picture will pop up. So I'll be talking about something and I think, oh, there's a great picture, and I'll click away and then show it to you and screen share it. I tend not to do that because I think that's very distracting. You don't want to sit there and watch me, reflecting the lights off my shiny head and pounding on the keyboard. Okay, here's a good one. Ooh, I like this one. You know what? And so sometimes what I do is if I get a good question that I think I can answer briefly, I'll do it as sort of a whole separate thing, and then when I get the video from this, I can edit just that part out and put it on the blog, and then it's just like a little 5-minute blip instead of this whole hour spiel. And this is a good one, so I'm going to do that with this one. So let me position. Okay. Hey, Phil Plait from badastronomy.com here, and I'm doing a live Q&BA video chat session. I got a good question from Jason Weitzel, and I hope I'm pronouncing that correctly, who asks, if NASA came to you and asked which moon had the best chance to find microlife, which of the famous 3 would you pick? Titan, Enceladus, or Europa, and how would you do it? This is a good question. One of the biggest questions we can ask is there life out there in space? We know there's life on Earth, Hello. And there's a lot of different kinds of life on Earth, and some of it's really weird. And we know that it can live in some fairly bizarre conditions here on Earth. But we think most of it, if not all of it, evolved from the same sort of proto-bacteria gazillions of years ago, billions of years ago, so it just adapted to the different niches on Earth. So they adapted to the high temperatures, cold temperatures, pressure, and all that. However, could there be life on other planets if the conditions there are good? Now, we know that life on Earth evolved, at least it arose, in conditions that were fairly harsh compared to now. And it probably got wiped out several times and popped back up again. So we think that the origins of life, given even rough conditions, pop up pretty easily. We think that life actually can get its start, get a toehold or a pseudopod hold or whatever, if the conditions are right. So where else are the conditions right? Now, I get questions all the time. What about ammonia-based life instead of water-based life? What about silicon-based life instead of carbon-based life like we have here? Don't worry about those. Those might exist, maybe. We don't know. We do know that life on Earth is based on carbon and needs water. So why not look there first? Okay, that makes it easy because we know those conditions work for life. So where can we find that sort of thing? And it turns out, we looked at Mars for a long time, and look, you know what? Mars may still have life on it. It may have evolved life at some point, billions of years ago, whatever. We're looking, and that's fine. But what's interesting is to ask, where could there be life now? And this question got juiced up pretty hard a while back when when astronomers figured out that the moon Europa around Jupiter actually is covered in ice and appears to have an ocean of liquid water beneath that ice. Now, we haven't seen this ocean directly, but as the Voyager probes and eventually the Galileo space probe orbited Jupiter and looked at Europa up close, the surface of it looks like ice flows. It looks like giant chunks of ice that are grinding against each other, and that surface is changing over time. I mean, you can see these kind of plates moving. Not only that, there are very few craters on the surface of Europa, and that means that the surface is being resurfaced. Every body in the solar system that has no erosion on it, our moon, Mercury, other moons of Jupiter, have craters covering them. So if you see a body, like a moon or whatever, that has no craters on it, chances are that means there's some process that's smoothing it over, resurfacing it. So we think there's an ocean underneath Europa's surface, and that water bubbles up sometimes and freezes and forms the surface again. Same thing with Enceladus. This is a moon of Saturn. Not only is it a lot like Europa in that it's very icy, we've also seen water directly because it has geysers blasting out from the South Pole. And we think that's caused by the force of gravity from Saturn. As Enceladus orbits Saturn, it gets squeezed by the tidal force of the planet, just like the Earth and the Moon squeeze each other as they go around each other. And so this is actually warms the Moon up, the same with Europa. And so that's why these tiny moons, I should add, are not frozen ice balls. They're actually being flexed, and that warms them up in the middle, and you get this liquid water. But in the case of Enceladus, this water's under pressure and shoots out of these poles, and we've seen that. You can look up pictures of the geysers on Enceladus. So Europa and Enceladus both have apparently liquid water, and we know there's tons of carbon out there and other stuff that life can be based on. So these are good places to look. And now Titan, which is another moon of Saturn, is huge. It's bigger than Mercury, has a thick atmosphere, which is rich in nitrogen, and it's been discovered that there are lakes on the surface made of apparently methane, and it probably rains methane on Titan. So there's actually sort of a liquid cycle, kind of like the water cycle on Earth. And it's difficult to figure all this stuff out. We don't have a super good view of Titan. The Cassini spacecraft is orbiting Saturn, and it passes by Titan on occasion, and it uses radar and infrared to pierce that thick atmosphere and map out the surface. But it looks like there's a lot of complex organic chemistry going on Titan. The question is there life? So to answer the question, which of these three would I say is best? You know what? I'm going to wimp out and say I don't know. I don't want to say that there's a best chance of life on any of these three moons. They all have something going for them. And I suspect very strongly that we should, in the next 20 years, I shouldn't say suspect, I suggest very strongly that in the next 20 years or so, we send probes, better probes to these moons to take a better look at them and see what's going on, to maybe even sample the surface of these things, or the atmosphere of Titan in this case, which we've done with the Huygens probe, with dropped by Cassini to land on the surface of Titan. But I'd like to see better labs sent to these moons to taste the chemicals that are there, to see if life could arise. That would be sort of the first question. And of course, to see if life is there. Now, you don't expect to see, little fish swimming around or anything like that. But there are definite signs of biological life that you can test for. And I think that is the sort of thing that NASA should be thinking about. The problem is very, very expensive. And this isn't maybe the time to try to make a very super ambitious probe. But it's something we should be keeping our minds to. Because this is a huge philosophical question. Are we alone? And for the first time in the history of mankind, we have a real scientific shot at answering that question. So there you go. That was probably longer than 5 minutes because I do tend to go on. But thank you, Jason, for that question. That's a great one. And I will refresh the chat room, and then I'll go back to Twitter. Let's see. That's a question I've answered in the past, as is that. Here's one I can answer in 10 seconds. We're all Stardust 9 asks, do you think NASA's design for the ion engine will ever be put into service for exploration to asteroids or even Mars? Yes, in fact, it's already been done twice. There are 2 space probes that have ion drives on them, at least 2 that I can think of right away. Deep Space 1 and Dawn, D-A-W-N. Dawn is, in fact, orbiting the asteroid Vesta right now. If you look up Vesta on my blog, you will find a dozen posts with close-up pictures of Vesta taken by Dawn. Dawn uses an ion drive, which is a very, very, very super low-thrust drive. Instead of giant chemical rockets, which blast out stuff at high speed, or hundreds and hundreds of pounds of material at high speed, it actually has an extremely low-thrust rocket that blows out ions at extremely high speed. It's not a rocket you can use to take off from the Earth because it doesn't have enough thrust to do it. But once you're out in space, you can ignite this thing and let it run for weeks or months or years. And at even low thrust, that builds up over time. So Dawn is orbiting Vesta now. It's actually going to leave Vesta some point this year and move on to the asteroid Ceres. And it's going to take a couple of years to get there, but it's going to use nothing but its ion drive to do that. So it's pretty awesome stuff. So just go ahead and look that up, and you will find your answer. So let's see. Climate science, Saturn. Oh, I just saw one. This is a good question from Mr. Boy, I'll tell you, you get onto Twitter late and you get ones that are hard to... Oh, here we go. Mr. Dude Boyman. Boyman or Boyman? I'll say Boyman, like Spider-Man or Batman. Batman was, of course, originally named Bruce Batman, but then changed his name to The Batman. Pardon me. Who asks, if Earth were to be threatened by an asteroid in the near future, how would we handle the situation? Well, we kind of already know in some senses because there have been asteroid threats in the past. I assume you mean a big asteroid. It's hard to say. I've wondered about this myself. But it depends a lot on the specifics. In the movies, right, it's always somebody discovers this asteroid. It's weeks or months or maybe just a couple of years away from hitting us, and there's panic or whatever, and the government tries to hush it up, or they send oil rig workers or whatever to blow this thing up. And that's not really right. The real situation is never that straightforward. For example, the asteroid Apophis, which it was a big deal a couple of years ago. People were talking about it. Now the odds of it hitting the Earth are probably only about 1 in a million. So astronomers, we're not terribly worried about it, but it becomes a good test case for looking at how we should characterize near-Earth asteroids. But Apophis was discovered in 2004, and it was not that long afterwards it was discovered to possibly be a threat to Earth in the year 2036. So that was a long stretch of time, and then it was quickly determined that it would probably not hit us. However, earlier this year, there were two asteroids that were found. One is 2012 DA11. I think that's the name of it, that passed by very close in February. And next February is going to pass within a few tens of thousands of kilometers. It can be a very close pass. And this is a fairly large rock. It's something like 40 meters across, so bigger than a house. And it would probably blow up in the Earth's atmosphere if it were to actually hit us. But next year, it's still going to miss us. We know for a fact it's going to miss us. The astronomers calculate its orbit. They include the gravity from the moon and the Earth and everything else, and they know it's going to miss us. But we don't know exactly what's going to happen after it passes us. It could have its orbit warped and then 5 years later come back and hit us. Most likely not. But it's interesting what happened. This was announced. And I wrote it up on my blog, and of course you get all these conspiracy theorists who are saying, it's going to hit us. And it's like, no, no, no. And then there are people who just don't understand the situation, and they wonder, did NASA account for Earth's gravity? Well, yes, they account for the gravity of all the planets and do all that kind of stuff and map the orbits forward and show that it doesn't hit us. There are conspiracy theorists who then come in and say, well, that's just what NASA's telling you. And that always cracks me up because it's not like NASA's the only group with a telescope, okay? There are people in Europe and Russia and Australia and countries that don't like us, like, China or whatever necessarily. I mean, the governments where we don't get along all that well. And they can map this just as well. And if it were going to hit us, they would probably say something. So it's always interesting to watch those conspiracy theories go. And of course, the media, who don't necessarily understand what's going on and might write something or talk about it without consulting with the astronomers who know what's going on first. So that can be very confusing. So there can be some initial panic, a lot of conspiracy theories tossed around, and then hopefully there are enough astronomers who come out and say, no, it's not going to hit us. But if there is one that is going to, in fact, you wouldn't be able to suppress that information. Astronomers would quickly find this out. It doesn't take that long. Once an asteroid is discovered and it's put up on the list, anybody can observe it. And you can go back in time and look for pictures of it that were maybe taken years ago by accident, where somebody was looking at just some spot in the sky and that asteroid happened to be in it. They can characterize the orbit really well and project it into the future and see if it's going to hit us. So, covering this up really won't work. What happens then depends on a lot of things. For example, there's another asteroid, 2011 AG5, which is a much larger asteroid, over 100 meters across. And this was discovered last year. And it's going to pass very close to the Earth in the 2020s. And you know what? 2023, I want to say. That doesn't sound right off the top of my head. But sometime in the future, it's going to pass near the Earth. And if it does it just right, if its orbit bends just enough, in the year 2040, it'll hit us. And this is a big asteroid. Now, the odds of this happening right now are fairly low. It's like 1 in 500. But that's still higher than I'm comfortable with. I'm not panicked or even worried that this thing is going to hit us. But it's something to go, you keep an eye on this. We don't want this thing hitting us. And so there were some folks who were trying to get NASA to at least sit down and figure out if we can plan a mission to do this. What's the best way to knock this thing out of the way if it's headed toward us? And NASA, the official NASA reaction was, well, look, the odds of this thing hitting us are extremely small. We're going to get better observations in September of 2013. Right now, the asteroid's in the part of the sky near the sun. We can't see it. But as it orbits the sun and we orbit the sun, eventually it pulls away, and it'll be up at night. We'll be able to observe it better. That happens in September of 2013. When we do that, we'll get a better orbit for it, and chances are, who cares? Excuse me. I said that out of order. Chances are, we'll see that it'll miss us, and in that case, who cares? We don't have to panic about it. Everything's fine. But after some pressure, I hate to use that word, that's not quite the right word, but after some talking to NASA and all that, NASA said, okay, you know what, that is a year and a half from now. We might as well look into a mission just in case it turns out that better observations show that this thing will hit us. The odds of that are extremely low, very low. Most likely it's going to miss us, and when we get better observations, we'll see that it'll miss us. And a mission analysis isn't that big of a deal. It's not like they're going to be building rockets or anything like that. It's basically just writing software to get good orbits for everything and figure out how to calculate the best way to get a rocket from here to there and push it out of the way and all that kind of stuff. And so that's good, and that's the kind of thing that should be done, and hopefully NASA is going to do something like that. So like I said, it really depends on the characteristics of the asteroid. If it's something huge that can do global damage, like something a mile across, yeah, people will jump on it. If it's something small, it's probably not that big of a deal. And if it's in between, maybe, maybe not. And then you start asking questions like, well, when's it going to hit us? Or when is it potentially going to hit us, I should say. Is it going to be in 5 years, so we have to be thinking about this right now? Or is it in 30, where we might have a couple of years breathing space to figure out what's going on? And even then, if it's on a certain orbit, it may be hard to get to it. It may take us 10 years to get there, and then we need that extra time to push it out of the way. There's just a huge number of things to think about. So it's unfortunately not like the movies. It's not like launch a nuke, boom, blow it up, and you're done. It doesn't work that way. So each case is different, which is why it's taken me so long to explain this. That's one thing I try to tell people. This is a complicated issue, and it's something we should be thinking about. They're out there. We haven't been hit by a big one since 1908, when something the size of a house blew up over Tunguska, Siberia. Those things happen every few hundred years, every few thousand years. We're not really sure of the exact rate, and it's random anyway. You could have one tonight, or there may not be one until the year 3000. But it's something we should be aware of, so that if we do see an asteroid with our number on it, we can do something about it. Pardon me. Where'd that one go? Dagnabbit. Oh, Jenny Winder. Winder or Winder? I'm guessing Winder. Jenny, you can correct me later. Says, what will I be saying at the 28th National Space Symposium? The National Space Symposium is a huge meeting of people, movers and shakers in the space industry that's actually down the road from me. I live in Boulder. This is in Colorado Springs, and it's a couple hours from where I live. And it's weird. I didn't even know this thing existed until recently. And it's a huge meeting. So I was very excited to hear about it, and I'm not going there to speak this year. I got involved a little too late, but I am going to be there next week on Thursday just to attend. And there's going to be this tremendous panel there called the Meeting of the Minds, Meeting of the Mega Minds. And it's, gosh, I have to think, it's who's going to be on. I'm not sure if they're on this panel, but several of the panels, there's going to be Neil Tyson, Bill Nye, Lisa Randall, Carolyn Porco, and a bunch of other, really smart scientist types. So I'm very excited to go down there and attend this and hang out with these. And most of these folks are old friends of mine, so it's going to be a lot of fun. I don't get much of a chance to see them. Carolyn Porco works here in Boulder. She's the imaging team leader for the Cassini spacecraft, and I hardly ever get to see her, so that'll be nice. So I'm not actually speaking there. Hopefully next year, get to do it, because this is a big deal. It looks like a lot of fun. And I would love to be on a panel talking about the future of space and the future of science in space. Can I give a shout out to Brianna Thomas? No. Oh, but you are asking, how many exoplanets have been discovered? That's a good question. You can actually answer this question by going to Google, and if you type extrasolar planet, and I believe this is one of those times when I actually will look down at my keyboard and type something. There are several places to go. There's the Extrasolar Planet Encyclopedia, exoplanet.eu. This is a good one. You know what? This is such a good question. I'm going to answer this one as a short Q&BA. So let me back out again and let me start over and do this one here. Hey, Phil Plait. Trouble pronouncing my own name. Okay. Hey, Phil Plait from badastronomy.com doing my live Q&BA video chat session for April 15th, 2012. And I got a pretty good question from Brianna Thomas, who asks, so far, how many exoplanets have been discovered? Now, exoplanets is a great term. I love that. It sounds very science fiction-y. Exoplanets! We used to call them extrasolar planets, but that's actually kind of a mouthful, and I like exoplanets better. These are planets orbiting other stars. And the first ones were detected in the early 1990s orbiting a pulsar, of all things, a dead star that had blown up as a supernova, an ultra-compact star, extremely dense neutron star, was left over, and actually several planets were found orbiting it. It wasn't until 1995, I believe it was, that a planet was found orbiting a sun-like star, a star more like the sun, that's actually fusing hydrogen into helium in its core and looks like a star. Since then, though, we've been discovering more and more. There are many ways of discovering them, and I'll answer your question. I'll give you an actual answer here. Just give me a sec. There are several methods for figuring this out. For example, here is my yellow tennis ball model star of science, and let's say there's a planet orbiting it. They both have gravity. So as the planet is orbiting the star, because the star's gravity is forcing, I can do it this way to make you see it better. As the planet's orbiting the star, it's actually tugging on the star as well. So they're actually making circles around a central point called the barycenter. It's essentially the center of mass. So this guy, which has less mass, is making a big circle. The planet's making a big circle, and the star's making a little circle that's opposite the planet's. It's hard to do. And you can detect that motion. Now, you don't usually physically see the star moving, although that's actually been done once. What's actually happening is that if the planet is tugging on the star and it's in, sort of like this, you're looking at the star this way, you can see a Doppler shift in the starlight. It's the same thing that makes a motorcycle go as it goes past you. That's sound, but the same thing works for light. And if you have a very sensitive telescope and the right equipment, you can detect that. And a lot of planets have been detected that way. Another way is if the planet's orbit is perfectly aligned so that it goes directly between you and the star, right? It blocks the starlight. It might, let's see, I'm going to do it this way. Here we go. It might go straight across the center of the star, or it might cut a chord across it, or just nick it, or whatever. But what happens when that happens is if you watch the star, you don't see the planet. You just see the starlight dip and then go back up as the planet passes in front of it. That's called a transit. And that method is being used by, for example, the Kepler spacecraft, which is staring at 100,000 stars, pardon me, staring at 100,000 stars for years, looking for that telltale dip in brightness. And Kepler's been doing a fantastic job. It's actually discovered thousands, it's something like now 2,000 planetary candidates. Now, these aren't necessarily confirmed planets because they've seen a dip in the starlight that looks like a planet. They might have even seen two dips some months apart. But you have to wait for that third dip. That's the critical one because it does it once, and you don't know what it could be. It could be a sunspot. It could be a star pattern. You don't know what it is. If it happens again, that establishes the period, 6 months, let's say, for the planet to go around the star. Then you wait another 6 months, and if it happens again, boom, you got it. So you have to wait for 3 of those planet years to see that. And it's found lots of candidates, but it's only found about 5 dozen, something like 60 confirmed planets. However, if you go online, there are lots of databases, lots of places where you can find information about extrasolar planets. There's the Extrasolar Planet Encyclopedia, which is usually quite up to date, has a lot of information about all the planets that have been found. With some things with Wikipedia, you don't know if it's accurate or not, but I have found that when it comes to topics like this, Wikipedia is usually pretty good. And looking at Wikipedia right now, under Extrasolar Planet, it gives a definition and all that, and it says right now, as of probably pretty recent, probably April, it says there are 763 confirmed planets, 611 planetary systems, that is 611 single planets orbiting stars, and 101 multiple planet systems, stars that have more than one planet orbiting them. Right now, I think the record confirmed is 6 planets, and there was one recently found, I just wrote about it, that may have 9. I think the 7th planet was confirmed. A little sketchy. It's not 100% that it has at least 7 planets, but we know it has 6, and it probably has 9, which is amazing. It's more planets than we have, given Pluto and all that. Don't worry about that. There are other things you can do. For example, if you have an iPad or an iPhone, Kepler has an app called, it's by Open Lab, University of California, Santa Cruz. I don't see the name of the app. It just came up and, well, whatever. It doesn't matter. If you look here, it has you can get a list of what kind of planetary systems you want to see. Sorry, there's a reflection there. And it'll put up a little map of the system, and you can make the planet go around the star and do all kinds of fun stuff like that. That's a really great app. The one I like is called Exoplanet. And this one says, oh, it's updating the database. As I'm sitting here, I can download. It's downloading the database. Ooh. And it says, discovered exoplanets 760. That's interesting. Wikipedia says 763. But I don't know which one is more accurate. But this gives you the idea. 760 confirmed planets orbiting other stars. Now remember, 1990, which is when I was starting my PhD research using Hubble, we didn't know of any. We had 9 planets on our solar system. This was before Pluto was called a dwarf planet. And there were 0 planets, 0 known outside of our solar system. Now, 20 years later, we know of approaching 1,000, and there's so many more discovered every year. This exoplanet database is great because you can see here's this big list of planets, and you can click through them, and there's diagrams and shows you the relative sizes and all that kind of stuff. There's all kinds of stuff for Android. There's stuff for your desktop. It's fantastic, and this is incredible because by looking at, especially with Kepler and with some of these other projects, by looking at these stars, what's happening is we're discovering so many planets that we're actually starting to get a statistical idea of how many planets there are in the galaxy. If you look at one star and it doesn't have planets, you don't really know anything. If you look at one star and it does, you can kind of say, well, maybe they're common if the first star we look at has planets. So, you want to look at as many stars as you can, and then you can say, oh, if 1% of them have planets, then maybe 1% of all stars have planets, as long as you have a big enough statistical sample. Kepler's looking at 100,000 stars. And these are all different stars. It's just a boom in the sky. It's just a part of the sky. So they're not picking sun-like stars. You're just taking a nice spread, a nice sample. And what we're finding is that a significant fraction of stars have planets. 10% more have planets at all. Now, only a fraction of those will have planets like the Earth, and only a fraction of those will have planets, at the right distance from the star to have liquid water or the conditions for life as we know it to exist. But the beauty of all this is that there are something like 200 to 400 billion with a B, billion stars in the Milky Way galaxy. So even if a tiny fraction, and you wind up doing all that math and say, only 1 in a million stars will have planets like the Earth with the conditions that are right for life. Yeah, out of 400 billion, 1 in a million is 400,000. 400,000 Earths. And I bet that number's too low. There are probably hundreds of billions of planets in our galaxy alone. Planets bigger than Jupiter, whatever. But I strongly suspect there are a lot of Earth-like planets out there. And in fact, I've been saying this for a while now, probably an Earth-like planet orbiting a sun-like star in the Goldilocks zone, in that habitable zone, where it's the right temperature for liquid water to exist on the surface. I bet that a planet like that is already in the Kepler data and has not been seen yet, because it takes a year to go around that star, or something like a year, and since you have to wait for 3 orbits, that means you discover it maybe the first day you look, then a year later, and then another year later, so it takes 2 full years to find that. Kepler's only been up a little bit longer than that. So it's not been able to completely confirm all this, and then the data is very fuzzy, it's hard to tell, but I strongly suspect that very, very soon we will be getting an announcement of a confirmed Earth-like planet orbiting a sun-like star in the habitable zone. I don't think that's too much farther in the future. So we went from no planets known in 1990 outside of our solar system to being able to find them, being able to characterize them, being able to get statistics on them, being able to predict how many there are in the galaxy, to possibly seeing, not yet, but possibly seeing an Earth-like planet in every sense of the word Earth-like. And we've done all of that in 25 years, less. It's incredible. This is a great time to be alive as far as science goes. So great question. Thank you. I really went on that. God, I always do that. But I get very excited about this. Let's see. Okay, nothing on Twitter again. So let me Let's see, I just refreshed. This is a good question. I get this one a lot. It's not really an astronomy question, but it's Ryan Day asks, I thought the moon, capital letters, was Earth's satellite. I see moons, uncapitalized, used often for other planet satellites, but thought that was as bad as calling other stars suns with a capital S. Is moon, little m, acceptable? There are rules for this. I find rules to be usually not terribly well thought out when it comes to grammar. I have all kinds of stuff. One of these days, I'm going to write down some of my grammar stuff because some stuff makes me just nuts, that the rules are just clearly bad. It's a holdover from some old Latin thing or old German or old English or something, and it just doesn't make any sense to do it now. It's interesting how this all works. When you talk about the moon, you are referencing the Earth's moon. Actually, that's not really a good model of the moon, but you know. It's just like when you say the Earth, or just Earth, think of it as a planet. So when I talk about Mars, I capitalize it, right? When I talk about Earth as a planet, I capitalize it. I sometimes still call it the Earth, which is silly because you don't say the Mars. But we do say the moon, the sun, the Earth, which separates them out from being planets. And I suspect that's a holdover from the time when we didn't really understand that Mars, Jupiter, Saturn, these other guys were the same sorts of things that we are, and our moon is, and the sun is. They're big, you know, they're worlds. The sun is a star, but, you know, big spherical objects in space, whatever you want to do. So we don't say the Mars, and we still do say the Earth, so that's silly. So the correct aspect is to talk about the moon, capitalizing it as M, and then any other moon, Enceladus, Titan, Prometheus, Deimos, and Phobos, you know, whatever moons you want to talk about. The name of the moon is capitalized, but when you refer to them as a moon, it's just a little m. So when I talk about Saturn's icy moon Enceladus, Saturn's capitalized, moon is not, and Enceladus is. But if I talk about Earth's rocky moon, the moon, I would say Earth is capitalized. The first moon would not be because I'm characterizing it as a moon, but then naming it, calling it moon. You can talk about stars being suns, but then you would not capitalize S. So I would say Alpha Centauri is a sun like our own. I would say Alpha Centauri, capital AC, is a sun, little s, like our own. And if you extrapolate that, then the consistent thing to do would be to talk about other solar systems using little s, and our solar system, capital S, capital S. I tend not to do that. I just say the solar system, little s, and that means ours. It's a mess. It's confusing. Languages evolve, and they follow events. So as we now are discovering more solar systems, maybe we'll have to change that, and more people will start capitalizing our solar system. I tend not to. That's probably wrong. I probably should. I'll have to think about that. But it's a habit, and it's hard to break. So there you go. I hope that answers your question. Let's see. Ryan Nosik is asking, is terraforming technologically feasible? That's a pretty good question. I think I've talked about terraforming before. The problem with answering so many questions is you get to a point where you don't remember what you've answered. And I probably should answer this as a short one, but you know what, I'm running out of time. So I'll just very quickly say, terraforming is the idea of taking a planet that's not like the Earth, say Mars, and making it like the Earth through various physical processes. So you're terraforming it. You're forming it to make it more like the Earth, terra. Technologically feasible? In general, in big picture, big idea terms, yes. Mars is smaller than the Earth. It has very thin carbon dioxide atmosphere, so it has less gravity than the Earth. But you could, in very general terms, make it more Earth-like. For example, it's dry and has a thin atmosphere, so we need to add water and air. How would you do that? Well, an easy way to do it is to drop comets on it. We have methods now. We don't have rockets to do this, but there's nothing in the engineering that says this is impossible. We have the ability to go to a comet and push it into a new orbit, which is good because you don't want it hitting the Earth, and so we can push it into an orbit that misses the Earth. So you could change the orbit of a comet such that its trajectory then intersects Mars, and then it would impact Mars. And comets are basically, if you pick them carefully, huge chunks of ice. So you could find a comet 20 miles across, like the old Hale-Bopp comet that passed by the Earth in the 90s. This had a 30-kilometer nucleus, which is roughly 20 miles, and a lot of that is ice, water ice. You drop that onto Mars, it explodes, and a lot of that stuff escapes, but some of it stays there, deposits a huge amount of water and other chemicals you can use to change Mars to make it look like Earth. Do that a few times, a few hundred times maybe, I don't know, a few thousand times, and Mars starts to look a lot more Earth-like. And I'm skipping over huge details. Now, you've got huge craters and all kinds of disasters are happening. But, technically, you could land chemical plants on Mars. They could take the soil. It's not soil, sorry, the regolith. It's a technical term. Soil is rock that has been dissolved by bacteria. Regolith is rock that has been broken down by non-biological processes, erosion and stuff. And on Mars, for example, one of the reasons it's red is that the dust on Mars has got iron and oxygen in it. If you break that down, you have iron and oxygen, air, yay! And so you can release that. You make chemical plants all over Mars, and they can break down the constituents in the surface and make it into water and air and all that kind of stuff. That takes probably centuries to do. But there's shouldn't be anything impossible about that. In theory, it should be possible to terraform other worlds. How you do it gets complicated. Like if you did it to Venus, it would be a lot harder. Venus has a very thick atmosphere and it's very hot. The technological challenges by terraforming Mars are probably a lot easier. How you would do this in reality, how you would be able to launch 1,000 rockets to drop comets onto Mars, and if you have that kind of time, and if you could get the public behind it and all that kind of stuff, totally different question. But is it technologically feasible? Yes. Yes. Pardon me. You know what? It is 12:06. I started a little bit late, but it's afternoon now. So I'm going to look down and see if I've got one more question I can answer quickly, and then we will call it for the day. Gosh, a lot of questions here. So, some of these are a little too technical. Some of these are a little bit tougher to answer quickly. Yeah, some of these are really good questions, but they're just hard to answer rapidly. Or there's specific things I'd have to look up first. And I've got a lot of information at my fingertips because I just read a lot, and I've been doing this a long time. But there's other stuff that's harder to answer without looking it up, like asking a question about a specific object or something like that. So yeah, these are a lot of good questions, but given that it's actually afternoon and all of those caveats, I think I will simply close down for now. I apologize to those of you who asked questions that I didn't get to. You never know when a question is going to be hard to answer. Sometimes what seems like a simple question can actually take a long time to answer, especially with me, right? Sorry about that. So for now, I'm going to close down. But let me leave you with a few things. One, don't forget, Saturn. Ooh, Saturn. Yee, Saturn. Again, binoculars are enough to see the rings. It's small. You have to hold them steady. If you can put them on a tripod, like this guy here, I've got my tripod with binoculars on it, and I take it out. It's going to be cloudy tonight, which I'm thankful for, given our drought. It's been raining, so that's good. But if you can't, if you don't have binoculars, you don't have a telescope, if there's a local observatory, local astronomy club, type in the name of your nearest big town or whatever and see if there's into Google with astronomy club or astronomy society and find out if there's one nearby. They may be having a star party sometime over the next few days. It's not critical you get out tonight and see it. Things aren't going to change that much over the next few weeks. And as a matter of fact, the longer you wait, although Saturn gets a little bit farther away and smaller, it's not by much, but the longer you wait, the earlier it rises every night. So right now, you have to wait a couple hours after sunset before it's up high enough to see. In a month, it'll be up by then, right when the sun sets. So it works out either way. Also, you can find me on Twitter at Bad Astronomer, on Google+, obviously, on my blog at Discover Magazine. I have a Pinterest board. I'm doing all kinds of ridiculous social networking stuff now, probably to the detriment of my writing ability. I'm going to be giving some public talks soon, or I'm giving some talks soon, but I don't know if they're public. I'll be doing one in Boulder, actually, in May, next month, and I'll have that up on my blog pretty soon. And a few other things. Space Fest is coming up. If you look up Space Fest IV, Space Fest 4, I'll be there. That's end of May, early June. And if there are a few other things I'm doing, I will have more information as that comes in. Also, Science Getaways, once again, if you go to sciencegetaways.com, this is my wife and I have started a company to add science to vacation packages. We're doing our first one in September, where we're doing a dude ranch in Colorado, and I'm very excited about that. You can do dude ranch stuff, just hiking, biking, horseback riding, fishing, all this great, amazing stuff that you can do in a week in the Rocky Mountains in Colorado, and it's gorgeous there, and the nights there are incredibly dark, and we're bringing in a geologist and a biologist to talk about the local science, and we'll go on hikes and look at the plants and everything and the rocks and all that, and there's a lot to see there. And then we'll be doing observing at night and maybe some solar observing during the day with moi, this guy with the two thumbs pointing at himself. So I hope to see some of you there. And that is it. Thank you very much. That is Q&BA for April 15th, 2012. I will not be doing this next week because I'll be on travel. I'll have to check my schedule. Just keep up on Twitter and Google+, and I will announce these, hopefully with some lead time, so you get a chance to listen. And thank you, as always, for the fantastic questions. I really appreciate it. Bye, everyone.